Now that we've studied the versatile nature of carbon as an atom and many other properties of carbon and carbon-containing compounds, let's move on and see how are these various structures of carbon, which is branches, chains, and circles, which are formed. So for that, first we need to know the list of carbon compounds. Now, one thing you need to remember is that in a carbon compound, you may have hundreds of carbon in one chain, but we're going to limit ourselves only to 6. So let's start off with methane. Methane is where you have only one carbon atom. Ethane is where you have 2 carbon atoms. Propane is where you have 3 carbon atoms. Butane is where you have 4 carbon atoms. Pentane with 5 carbon atoms, and hexane with 6. Now, if you notice the names, you might feel that it might be difficult to memorize them, but to make it easy, if you look at pentane and hexane, they are named after the shapes hexagon and pentagon. So it might be quite easy to memorize them. Now, let's study their shapes. First, you have methane. Methane is only a single carbon atom, and hence nothing can be done about its structure. So you just have CH4 as it is. Then you have ethane, where you have 2 carbon atoms. And again, no matter how much you play with the structure, you're going to end up with a straight chain only. Then you have propane. In propane, you have 3 carbon atoms, and hence nothing can be played around much. Now, butane is where things start to get interesting. And butane is where you have 4 carbon atoms. They are usually found in chains, and hence we call this chain of butane as N-butane, which is the normal butane. And what if you take 1 carbon atom from the end and put it as a branch somewhere else? Now, the only place you can put it as a branch and it would look like a compound is at the 3rd carbon. And if you look at it now, it makes at the 4th carbon, and it makes a different tree-like structure, and this is called as the isobutane. Now, when you look at the pentane, a pentane can again be formed into 3 different structures, and hexane can also be formed into a circle shape, which is called as a cyclohexane. Now, these different structures of carbon atoms are generated from the same molecular formula. And when you have the same molecular formula but a different structural formula, you call these as isomers, or rather better as structural isomers. Now, from the properties of carbon, we also know that carbon has a valency of 4. That means it can combine with 4 other elements or atoms. Now, whenever you talk about carbon bonding with 4 other elements, more specifically, it can bond with other elements or atoms like halogens, which specifically would be chlorine and bromine, even fluorine. And then you can also bond with oxygen, nitrogen, sulfur. But right now we're going to talk about 2 specifics. One is a halogen group, the other is oxygen. And whenever you have carbon bonding with these, it is in the form of something called as a functional group. So whenever you have carbon bonding with a halogen, maybe chlorine or bromine, you have a chloro or bromo or haloalkanes which are formed. Now, these haloalkanes are nothing but a halogen which is attached to the basic carbon chain. Then you have the oxygen attached. Now, oxygen are usually not directly attached, but when they are attached, they are in the form of a functional group. Now, this functional group may be either alcohol, which is OH, carboxylic acid, which is C double bond O OH. Then you have ketone, you also have aldehyde. So these are functional groups, and these functional groups also give the basic carbon chain a new property and some new characteristics. And in today's drug chemistry, these functional groups have a major role to play, as every functional group has certain property. For example, in homeopathics, the alcohol that you have is used as a solvent for the medicine. Even in the laboratory, Alcohols are used as certain kind of solvents to dissolve a substance or a dispersant. Even in your perfumes, you have alcohol. So this is all about the functional group.